Hi, this is exercise 2 in our lab manual, and we talk about microscopy in that exercise. So when we take a look at the microscope, we'll first talk about the ocular lenses. The ocular lenses have a 10x magnification power. The objective lenses in the microscope, there's a 4x, a 10x, a 40x, and a 100x objective that can all rotate into place. Which means if you have the 4x objective lens in the place and you have 10x lens in the oculars, you'd have 40 times magnification going through the scope. The other thing that's important to look at on the scope is the stage, and we can move that up and down with the coarse focus knob. It's how you're focusing the microscope. The condenser is down below the stage. It's responsible for focusing the light through the microscope. That can be moved back and forth. I suggest you keep that all the way up so it maximizes the amount of light going through the scope. This lever here is the iris diaphragm, and you can move that back and forth to allow different amounts of lights to come through this microscope. To turn the microscope on, you use this on switch and we get light to come through. A lot of times the light does not come on, and that's typically because these plugs get quite loose in the back of the scope. So if the microscope light doesn't come on, try pushing this plug further into the scope, and then the light on the microscope should come on. The other thing that's important in microscopy is resolution. Resolution is the ability to separate two distinct objects. So if we have poor resolution, you might see something like the outline of my hand. If we have better resolution, you might have the ability to see between all my fingers. Resolution is based on wavelength. So light has a relatively long wavelength. If you have a long wavelength, you might not be able to distinguish the fingers. If you have a shorter wavelength, like an electron microscope, it has a much shorter wavelength, and you'd be able to distinguish something like the difference between my fingers. So the other thing we do in exercise 2 is take measurements of the organisms we're looking at. Typically, to take a measurement of an organism, you need to calibrate the little ruler that's in the ocular lenses. You do that by having a stage micrometer that you put onto the scope. You use the tiny ruler in the stage micrometer to measure the distance in the ocular micrometer. Because distance, relative distance, is going to change each time you change the magnification by changing the objective lens, you have to calibrate or measure this ocular micrometer at each different magnifications. We don't have stage micrometers at Red Rocks, so we don't do this portion of the lab. Nonetheless, we do want everybody to be able to measure their organisms, so we give them the approximate calibration of the ocular micrometer based on each different objective lens. We give the students a table with the conversions so that they can measure between the ticks of the ocular lens and convert it to microns of length for each of those specimens. At the end of the first day, we want everybody to have 2 drawings of eukaryotic organisms with measurements. So I am going to go ahead and demo focusing the scope on a eukaryotic organism. So we turn the scope on and make sure the light is all the way up. You then take a slide and put it all the way back into the slide holder and move the stage back and forth to focus on the organism. So we'll start at 4x objective. You move the stage all the way up and then slowly move the stage down until you focus on the microbe. Then move the microbe to the very center of your field of view. Make sure it is well focused Because these scopes are parfocal, if it's in focus on the 4x objective, it will be in focus on the 10x objective. We'll now click the 10x objective into place using the fine focus knob. You'll make small adjustments to make sure the organism is in good focus, and you'll adjust it again, bringing it to the center of the stage. We'll go up in magnification one more time. We're now using the 40x objective, so 400 times total magnification. So once you've got to 400 times magnification and you are looking at the organism, we also want measurements of the organism taken. You will look at the objective micrometer. You will count the small ticks in the objective micrometer. You will then convert the ticks to microns, and you will write down how many microns the organism is in the lab notebook with the drawing. Make sure you properly label the drawing with the organism, the magnification, and the microns of your organism. The second day of laboratory with exercise 2, we have people look at prokaryotic organisms. And the overall goal of the exercise is to have 3 drawings of prokaryotic organisms, all with the measurement and the ruler drawn into the notebook. With prokaryotes, which are much, much smaller, you need to have better resolution in the scope. To have good resolution, we have to have the light coming into the lenses of the microscope. To refract the light into the microscope lens, you need to put oil onto the slide before going up to the 100x objective. If we are in focus at the 40x objective, we will then move halfway between the 40x and the 100x objective. You will take the immersion oil, and 1 drop of the immersion oil will be put onto the slide. Try not to get oil anywhere else onto the scope. In addition, try not to touch the slide with the applicator, as we do not want to contaminate the oil. Once there is oil on the lens, you can slide the 100x objective into place. You'll see the light change slightly when the lens hits the oil, and you can then use the fine focus only to focus on your organism at 100x objective or 1,000 times magnification. Because prokaryotes are so small, often when you get to the 100x objective, the microbe seems to disappear out of the field of view. It is actually quite a bit easier to start over from the beginning at the 4x objective lens than it is to spend 10 minutes trying to find focus. The concern with this is that the 10x objective and the 40x objective are not oil-proof or waterproof. You cannot get oil on that 10x or the 40x objective, or the oil sneaks behind the lens and makes a very cloudy view. So if you need to redo from the start, you need to move the stage down, remove the slide. There's now oil on the slide because we don't want it on the other objectives. You will take a Kim wipe from these green boxes and wipe off the oil on the slide. Please make sure not to use a Kim wipe on the scope. They are actually fairly rough and you will damage the lens. You will use lens paper only on the microscope. You'll take a piece or a half piece of lens paper and you will push it up into the 100x objective. You can hear this click. If you have oil on the lens paper, you need to continue blotting it off the 100x objective until you get a clean piece of lens paper. You can then take your prokaryotic slide, put it back into the microscope, adjust back to the 4x objective, bring the stage all the way up, and begin refocusing on the organism. Once it's focused at 4x, you can turn to 10x, refocus with the fine focus, shift to 40x, Again, refocus. Make sure it's well in focus and right in the center of your field of view. So at 1,000 times magnification, our ocular micrometer is set so that 1 micron is equal to 1 tick. So you can see the bacterial chain right here. So here's 1 bacteria, 2, 3, and maybe 1, 2, 3, 4, 5 coming up in this direction. So if we count how many ticks, and they're the small ticks, this bacteria here it's 1, 2, 3, 4, 5. If it's 5 ticks long, and you multiply that by 1 micron per tick, we have an estimate that this bacteria right here is approximately 5 microns long. To put the microscope away properly, we need to move the stage all the way down. Make sure to remove the slide. Clean the slide off with a Kim wipe. Make sure all the oil is removed. In addition, you need to make sure you've used lens paper to clean off the 100x objective lens thoroughly so there is no oil left on the lens paper. You will then click the 4x objective into place. It has the biggest distance between the stage and the lens so that the lens won't be damaged. You'll turn the light off on your microscope. Stage should be all the way down. You will unplug the scope, coil the cord up, and secure the cord. And then you will use 2 hands to carry the microscope back to the closet and put it in its proper spot.